Okey-doke.
Okay, in this next lab, we're going to demonstrate the vertical milling machine. And we have several vertical milling machines here in the manufacturing processes lab. This one happens to be a Pro Max. To the right, there's a Willis, and we have two more. We have another Pro Max and a Super Max. All the same type of machine. Again, this is the part we cut on the horizontal bandsaw last week, the chop saw. We just cut it to a rough length. I'll get the blueprint. Our blueprint said the rough length was 3 5/8 inches long. The finished size of our part is going to be 3 inches 5/4-3. So what I have to do is I have to face off one edge, and then we're going to take a measurement. We'll flip it over and bring this to size on the vertical milling machine. Okay, the vertical milling machine at this point has no tooling in it. This is our 2-flute end mill, and I'm going to put it up in the machine, but there's nothing to hold this in place right now. So what I need is a collet, and this will fit in the collet. The collet will shrink down and grab a hold. What holds the collet up in the machine is what's called a drawbar. This is our drawbar. They're pretty long, and the drawbar actually fits in top of the machine, goes all the way through the machine, and comes out towards the bottom. And what happens here is I'll put this in, screw the drawbar in the bottom of the collet, and as I'm screwing it in, it's pulling this collet up against the taper, and that will grip my tool. So here's the collet I'm going to use, a 1/2-inch collet to match our 1/2-inch tool. I'll put it up in here, and I'll reach up on top of the machine and start tightening this up. Then I can put my tool up here. Now you have to be very careful when handling these tools. The edges are very, very sharp, so I'm kind of staying away from that. If I let that slip out of my hand, I'll probably get cut, so I want to be very careful. And now I have a special tool that we're going to tighten up. Drawbar, and that's it. So our tool is secured in the machine. Now if I put my workpiece, the blank in the machine, it's going to sit way down here, and we may hit somewhere on the machine. So what I need to do is get this up in the air a little bit so our tool can go through with no problem. This is what's called a set of parallels. Parallels, there's two pieces of steel each. These are ground very accurately, probably within a couple tenths of a thousandths of each other. They're supposed to be parallel. And choose the proper size parallels, set them in here. Now my part will sit right on the parallels. And when I tighten up the vise, it'll hold it right in place. Okay, now I want to make sure I get it good and tight. I don't want my part lifting out of there. Okay, now I've got quite a distance here. I can bring my quill down some. That's a long ways to bring it down. So what I'm going to do is I'm going to crank the table up. This is called a knee mill. So the knee, this part here, actually can lift up. We can have a shorter distance or a longer distance depending on the size of the part. So I'll crank it up about 20 or 25 turns here to get it up to a workable level. Okay, that's pretty good. And I always turn my handle around so I don't bump into it. All right, now be sure you always wear your safety glasses when running mills or any machine tool. No gloves, no ties, jewelry or anything. Take your watch off. Make sure everything that can get caught in the machine is out of the way. I'll move my drawbar out of the way. And what I'm going to do now is bring my tool down and lock it in place. Okay. So I'll turn the machine on, and I'm going to bring the table over. I'll move this box. I'm going to bring the table over so it just contacts the workpiece. There we go. There's an X axis and a Y axis. Right now I've got the X axis up against the part, and I'm turning the Y axis. And I just want to face this edge off. I want to get a good surface finish, nice flat surface. I'm probably going to do this twice. Barely touching on this end. Okay, so what I have here is a digital readout, DRO. And I can put the X axis to 0, the Y axis, and the Z if I want to. We won't worry about the Z. Right now, the X axis is what I'm working with. So what I want to do is take maybe 5/1000ths of an inch off, 0.005. So I will turn this till I get to 5/1000ths. There we are, 0.005. What I did was I advanced the tool into the workpiece about 5/1000ths of an inch. I'm going to spray a little WD-40 on the part, and this will give me a little better surface finish. These are manual machines. I have to crank the machine in the X and Y by hand. And be careful, you don't want to go too fast. You don't want to break the cutter, or you don't want the part to fly out of there. And I'm going to take it back across. Okay, and we'll turn the machine off. Always let the machine go to stop before you put the part out, take the part out or measure it. So I'll take the part out. And now we have a pretty decent surface finish there. That was a rough sawed cut before, and you can see the other side. Okay, now what I need to do is I need to measure this. So I'm going to take my calipers, and we will measure this part. Right now we have 3.665 inches. We need 3.543. Okay, so I'll put my part back on the parallels, but I'm turning it around. This is the way we did it initially. We're going to turn it around because I want to clean up the other side as well. And tighten it up. What I'm going to do is just take a skin cut off of this, and we'll see where we're at. So we can move this over. Move the table up just a little bit more. Okay, now bring it into the touches. And we're going to make a skin cut off of this end. The other end is finished. And we will measure this. 3.668. 3.668. Okay. If we take our calculator, go 3.668 minus, we wanted 3.543. 3.543. We need to take off 125/1000ths, an eighth of an inch, to get this to the right length. I cannot go an eighth of an inch all at once. That's way too much material for the cutter. I'll go in about 30/1000ths of an inch at a time. Okay, so I made a cut across here. I can set my X to 0. I can do the Y too. The Y we're not worried about. Now, I said we can do 30/1000ths at a time. So what I'm going to do is move my cutter, or move my table into the cutter 30/1000ths of an inch. There's 10/1000ths. There's 20/1000ths. And it doesn't have to be exact. We're going to get better later on. So there's 30/1000ths of an inch. Okay. I'll add a little cutting fluid. And we'll cut across here. Now we're at 30, I'm gonna go to 60. I'm gonna take another 30 thousandths off. 50. Pretty close. Remember, we gotta take 125 off, so then this will be 60. Right now we're doing a conventional cut. You can see the chips are being forced away from the cutter. This is a conventional cut. And then I'm going to go another 30. Make that 90. Again, it doesn't have to be perfect. This is a climb cut. You can see the way the cutter is cutting. It's actually cutting into the workpiece. You can get a little bit better surface finish on a climb cut, but your machines have to be very tight. They have to be good, otherwise it tends to pull the part along. What I'm going to do now I'm going to go in about 15 thousandths more. So I could add 15 to that, or I could just go to 0 again and say I'm going to go 15. Cut it, go back. Now you always want to make sure that you either clamp your part directly to the vise table or to the mill table, or clamp it in a vise, and the vise is secured to the table. Okay, now what I'm going to do is I'm going to take another measurement, but I'm not going to pull the part out of here. I'm going to leave it right in there. And we'll see where we're at. Right now we have 3.559. 3.559. All right. So we have 3.559 minus 3.543, 16 thousandths. I tried to leave myself about 15. It says I have 16 thousandths of an inch to go, 0.016. Okay, because I have not removed the part and I didn't change anything, I can just go back to 0, take my 16 thousandths, try and get it as close as I can. It's not, we're allowed 6 thousandths of an inch for our tolerances, plus or minus 6. Little cutting fluid there. Now we'll go across it one more time here. All we're doing is bringing our part to the proper length. And this is also going to square the edge up. Okay. Now, if you're real confident in all your numbers, you can take the part out and measure it, but I like to measure the part one more time while it's in the machine. 3.543. What do we need? 3.543. Well, that doesn't come out that easy, that good all the time, but we have it. So now our part is exactly to length, according to the blueprint. We were allowed plus or minus 6 thousandths, so I could have been 6 thousandths longer or shorter and still been okay. Now, we have a good surface finish on both ends. Everything's nice and square. Looking at our blueprint, I'll get the blueprint out again. There's several things that still have to be done. We're going to have to cut this out. Well, we did that last week on a different part on the vertical bandsaw, and we'll finish that next week on the milling machine, on the CNC. Right now we're going to have two 45-degree angles here. So to do that, it'd be kind of tough on this machine here. I'd have to try and work both handles and try and do a 45-degree cut. But what we're going to do is step over to our last mill, fixture. We still have our vise, nice Kirk vise, and this table here, we can rotate our part in the vise. So there's a mark right here, and that mark, when it's at 0, now we're square with the table and the head and everything is right where we want it to be. But I said these are 45-degree angles. So I'm going to move this till that pointer, there's 10 degrees, 20 degrees, 30 degrees, 40, and it has a long line, 45. Good. Now we'll tighten these two bolts. There's one in the front and one in the back. Tighten them down, and we have our 45-degree angle. So this will make nice square cuts. Okay, now these are my guides here. I have to cut back to that line. So what I'm going to do, this vise does not need parallels. It has a little notch cut on both jaws, as you can see there. So the part will actually lay right on the jaws. I want to hang the part out over the edge some and then tighten the part up. The reason it's hanging over the edge, we don't want our cutter to hit anywhere. So there we are. Okay. So now I can make straight cuts. Because I've got my angle on the vise, all I'm going to do right here is, on my y-axis, just bring it in, start cutting the end of the part off. I'm just doing conventional milling on this machine. It tends to want to grab the part at an angle. And you can see, just by turning the y-axis, straight cuts, we're getting our 45. We're almost to our line. Shut this off for a second. Still have a little ways to go. I'll move that over. You can see we're almost to our line there. So a couple more passes and I'll have that side done. We don't need to set up a digital readout in this one. This is more for aesthetics than anything else. I just caught that line. So that's that edge. Now we're going to do the same over here. And now I'm just going to use the x-axis. Again, these are manual machines. I'm cranking the table by hand. Those two lines were previously put on there just to save time. And I think I'll go one more. Okay. So now, I stopped right at the line. I went just a little past it now, it's okay. And it's going to look something like our part will look here according to the blueprint. And that concludes today's lab on milling machines.